Welcome to our presentation on network protocols. Today, we'll explore the fundamental protocols that enable communication across networks, from basic data transmission to complex application-level interactions. Ethernet is the foundation of most local area networks. It operates at the data link layer, defining how data is packaged and transmitted. Ethernet uses MAC addresses to identify devices and employs CSMA-CD to manage data collisions on the network. Internet Protocol, IP, is the core protocol of the Internet, responsible for addressing and routing packets across networks. We have two versions, IPv4, which uses 32-bit addresses, and IPv6, with 128-bit addresses to accommodate the growing number of Internet-connected devices. APIPA is a feature in Windows that automatically assigns an IP address when a DHCP server is unavailable. It uses addresses in the range 169.254.0.1 to 169.255.255.254, allowing devices to communicate on a local network even without proper IP configuration. Transmission Control Protocol, TCP, is a connection-oriented protocol that ensures reliable, ordered data delivery. It uses a three-way handshake to establish connections: SYN, SYN-ACK, and ACK. TCP is used for applications requiring data integrity, such as web browsing and email. UDP, User Datagram Protocol, is a connectionless protocol that prioritizes speed over reliability. It's used for applications that can tolerate some data loss, like streaming media or online gaming. UDP doesn't guarantee packet delivery or order, but offers lower latency than TCP. HTTP is the foundation of data communication on the web. It defines methods like GET for retrieving data and POST for submitting data. HTTPS is the secure version of HTTP, using encryption to protect data in transit. HTTP typically uses port 80, while HTTPS uses port 443. HTTP status codes are three-digit numbers that indicate the outcome of an HTTP request. They're grouped into 5 classes: 1 XX for information, 2 XX for success, 3 XX for redirection, 4 XX for client errors, and 5 XX for server errors. For example, 200 OK means a successful request, while 404 not found indicates the requested resource doesn't exist. Domain Name System, DNS, translates human-readable domain names into IP addresses. It's a hierarchical, distributed system that allows us to use memorable names like www.example.com instead of IP addresses. DNS typically uses port 53 for both TCP and UDP traffic. RDP, or Remote Desktop Protocol, allows users to connect to another computer over a network connection. It uses port 3389 by default. SMB, or Server Message Block, is used for file sharing and operates on port 445 in modern versions. Both are crucial for network resource sharing and remote access. DHCP automates the assignment of IP addresses and other network configuration parameters. It uses ports 67 and 68. SSH, or Secure Shell, provides a secure channel for data communication and remote command execution. It operates on port 22 and is widely used for secure remote access and file transfers. FTP, File Transfer Protocol, is used for transferring files between a client and server. It uses separate ports for control, 21, and data, 20, connections. Telnet provides a command line interface for communication with remote devices using port 23. However, Telnet is considered insecure, and SSH is generally preferred for remote access. These protocols form the backbone of network communication. Understanding them is crucial for anyone working with networks or developing networked applications. Each protocol plays a specific role. from basic data transmission to secure remote access and file sharing.